y'all when y'all are doing this, because the only way I learn something is for me personally is when I teach it or have people y'all ask questions about it. It seems to help make it easier for me. Oh, I don't think I did that right. Okay, see if somebody checks if I got that right. I'm having one of those days.
I think you just clicked the wrong one.
I think I did too. All right, just a second. I love this stuff. Share the screen. I need this one. I think you're right. I think I did that wrong. Thank you, dear. Okay, so I'll get this out of the way. So what you'll see in other videos, I did a quick overview of the immune system, and very interestingly enough, several functions. This is the first question on that sheet. But one of the most bizarre things is obviously the lymphatic system regulates this interstitial fluid. And I will go back over this, and I think it's important for y'all to kind of follow it, especially since I don't have video up, y'all can get a chance to watch it yet. But y'all remember that capillary exchange question that y'all got on the chapter on blood vessels? And we will have some arteries and veins, right? So superficial arteries and veins is on the list, right? Make sure you know that. I'm going to do those two pictures, right? Supervision. I'll probably send out an email this weekend. Y'all please check y'all's inboxes, okay? I got some people that don't check their inboxes, but I'll probably go back over all of them as I may not do this. I'm going to make you label superficial arteries and veins. So I'll probably have 5 or 10 points of arteries and veins on the test, okay? Just that picture, remember, just the one front and rear end view, right? No, just front view of arteries and veins. So one of the arteries and one vein, okay? So there will be a little bit of labeling for probably no more than 10 points, okay, for the test. But y'all remember the other question I guarantee is going to be on the test is the capillary exchange where we had the arterial side of the capillary bed and then the vein side, right? Remember that one? Okay, look at this. I'll kind of show you the picture. Here's the picture of what it looked like. I'm jumping ahead a little bit, but remember this right here? This is the capillary exchange here. Remember the arterial side and how the hydrostatic pressure from the heart pumping pushed the water out of the capillary bed. And remember there are little holes in the, remember those fenestration little holes in the capillary beds that can't let the white blood cells, the red blood cells out. You know, they're too big. They're too big to go through the hole. Kind of like a coffee filter. You know, the grains are not supposed to go through the filter, right? But the essence of the coffee and the water goes through into your coffee cup. So water gets pushed out on the arterial side, remember? And I want you to know those numbers. Then on the vein side, the water gets pulled back in due to what? Remember? That colloid osmotic pressure. Those proteins, plasma proteins made by the liver and the plasma of the blood pull that water back in by osmosis. Kind of like, remember me telling y'all how you can take salt water, put it in your mouth, and pull the water out of the little bumps. Sometimes we get a little fever blisters we get in our mouth. That'll suck the water out of the fever blister into your mouth, and you spit that water out. So the plasma proteins in the blood are going to pull the water back in. So what we do at the capillary bed is the water leaves the arterial side, feeds the cells. They get all the hormones, vitamins, minerals, nutrients they need, and then they even throw their products out. And then on the vein side, all that gets sucked back in. But what was the problem in that picture that's on your test? That there's more blowing out than there is being sucked in on the vein side. Remember, the pressure wasn't equal. So there's a net buildup of fluid out here in this interstitial space. Everybody remember that? If not, I'm kind of going over it again. So we got a problem. We have edema is one of the terms of this chapter is swelling. Well, God has another set of tubes called the lymphatic capillary beds called lacteals that collect all this extracellular fluid and carry it back to the heart via there. Now they're not green, but we always draw them green in the book because we like to arteries red, and they're not red either. Okay, but they contain oxidative blood. Veins contain what? Unoxidative blood, so they're kind of drawn blue. And for some reason, we pick green for lacteals. There are no green tubes in these. Is that clear? But the fluid does pull back. So these work like veins. They carry this excess fluid back to the heart. Okay. And the picture of the woman with the arm, I'll show you in a minute, right? That's where they have screwed up her lymph nodes and the lymph not draining her arm. Terrible disease called elephantitis. These protozoans get into your lymph vessels and climb up in your legs, and your legs swell the size of an elephant. Google that sometime. And it does a really bad thing on the boys. It gets in the scrotum, and the scrotum gets this big, which dragging the ground. So it swells up and big your leg. Very, very disturbing. Okay, it has to be lanced. Okay, you don't want to do that. You don't want to run into that. You may even have to have parasitic growth if you go to third world countries because of this in the environment. Okay, but I say all that is to explain one of the functions of the lymphatic system is to what? Carry excess cellular fluid back to the heart. And so why is the lymphatic system and the immune system put together? Well, along these pathways, there are these structures called lymph nodes that filter this lymph for pathogens. lymph nodes are clusters of B and T cells and monocytes and neutrophils that eat all the foreign particles in that lymph. And so it's kind of like one, I call them little ambushes, right? So it's like an ambush after an ambush after an ambush, and eventually the pathogen is killed. So the reason these two are put together in a chapter is that the main place where the cells that do immunity hang out are in the lymphatic tissues. Specifically the lymphatic vessels, the lymph nodes, and then we have the spleen, which is a big organ in the lymphatic system that filters the blood for pathogens, okay? Lymph nodes will filter lymph for pathogen, right? Okay, and then there are Peyer's patches and tonsils, and you know, some of y'all had your tonsils removed. Those are also areas of immune cells. So we put these together. Okay, that was a whole lot, but I wanted you to understand that. So one of the big things it does is it regulates this interstitial fluid. You make over 2 to 4 liters per day. So you would have swelling, right, if this lymphatic system don't work. It also regulates what's in the interstitial fluid, right, and that's big time. Here's one you may not know. Did you know that all the fat in your body is absorbed into the lymphatic system? It does not go into the digestive system. Excuse me, into the bloodstream at the digestive system. So at the small intestines, and those little fingers called villi, there are capillary beds that pick up water, proteins, sugars, and nucleic acids. But it is the fat that's put into these little green lymphatic vessels called lacteals. So for some, and I can tell you why, it's because the fat is bigger and the holes and the lacteals are bigger than the holes in the capillary bed. So they can handle this bigger fat protein, this big fat particle. Okay? So all of your fat is absorbed in the lymphatic system. It goes to the heart, gets stowed into the cardiovascular system of the heart, and it goes to the liver for processing. That's pretty cool, isn't it? So that's what I didn't know. I did not know that when I took the physiology. I'm like, what? You know, that's kind of weird. So fat's absorbed here. And of course, the immune cells hang out in these lymphatic organs. That's the main reason these two are in this chapter. Why these two are together. Okay. So on the video, all this is on the video that I'll put up this afternoon, probably because I think there may be another class in here, so I have to come back in here in the afternoon and upload them to YouTube and link them into our shell. But here we got, and then basically what we did is we went through all the different organs, right? The drainage is kind of weird. We'll see in just a second. The left brachiocephalic gets most of it, right? Look, so all of the lymph from the whole lower trunk and left arm and left side of the head all drop in right here in the left subclavian. Only the right arm and right side of the head drain into the right subclavian, which is kind of weird, right?
Is there a reason for that?
I have no idea. That's a great thing. I do not understand that one. Just one guy did. One of those little weird things. You know, I mean, life is not fair. We're not all, I'm the ugliest person in the room. That's not fair, right? I should be, we should all be average looking, right? And we got a room full of beautiful ladies in here, my ugly old self, right? So that's not fair. Okay, but yeah, it's a good question. I don't know why. That's a good one. Okay, and it talks about how the lymph is flowing in here. It works the same way as veins carry blood back to the heart. Remember, the veins go through muscles squeeze, and they have valves to prevent backflow. So the flow of the lymph is the same way that we get flow of blood back to the heart. Lymph nodes then are these little ambushes for these lymphatic tissues, right? Edema is extra buildup interstitial fluid. Here's this woman's arm. She had breast cancer, and they removed some lymph nodes in under her arm, and it messed up her lymphatic drainage, and now her right arm is swelling up abnormally. Now, one of the things I want you to know is when we look for cancer, that's sort of the first place we look at is the lymph nodes after we identify it in the organ. Because all cancer spreads in the lymph fluid before it goes in the bloodstream. So matter of fact, we call stage 1 cancer is having cancer in one organ, but not in the entire organ. So let's say you got kidney cancer. A friend of mine had this a couple years ago, and it was not spread all through the kidneys. So that's stage 1. Stage 2 is spread all through the organ. Stage 3 if it's in the lymph node. Stage 4 if it's in another organ. So stage 4 would mean the cancer is spread from my colon to my bone. The bone cancer is really bad. Bone into the other organs. Okay, so just one organ with it would be stage 4. Okay, other lymphoid tissues, and what's in there? B and T cells, macrophages, which are phagocytic cells, dendritic cells, reticular fibers, right? Make the matrix of this. So remember reticular fibers. Remember I showed them hairnet meshes, and they are very prominent in lymph nodes and spleen and the lymphatic organs. Here's the lymph node. We looked at this as reticular connective tissue, remember, when we had histology earlier. Another one are mucus-associated lymphoid tissues, MALTs, and these include things like tonsils, appendix, Power patch. Now we had a big argument what the appendix was, function. Thought I had a picture of appendix, sorry. Remember, that is that dead end pouch between the small ducts and the large intestine. We now think this is a storm shelter for good bacterium. So your colon is a turf war between the crypts and the bloods, or whatever, okay? And you want one of the one, I don't know which is the good one of them, so but you want these helpful bacterium in your colon. And when you get a diarrhea or some other disorder that blows all of them out, then these guys come back out of the appendix and receive your colon. A lot of research and a lot of people looking really now at the colon, and some people may be healthier because they got certain bacteria in their colon that other people don't have, just random luck, okay? So that's been associated with some degrees of different health. Prior patches are areas along the digestive system, small intestines, where they are located. We know what tonsils are. Here's tonsils, right? And these are areas of defense, lymphatic tissue that can be removed and you're going to be fine. There's our appendix. So that one, you can have that removed and be okay. I probably wouldn't want to have my spleen removed, okay? Here's prior patches below the simple clumbar epithelium, right, in the intestine, because where are we going to pick up infectious agents? Mouth, breathing, nose, respiratory, food we eat, digestive system, reproductive structures, vagina, penis, whatever, okay? And of course, the anus would be an area where things can get infected there too. Anywhere you have openings, okay? So these prior patches are areas of defense under where the food comes in, because a lot of our food is contaminated. Lymph nodes, we already said. Here's a lymph node. That's actually about the size of your finger, okay? About like that. That looks like one in the inguinal area of the leg there, and that cadaver. And you can see all the tubes come in, but all the lymph comes out one tube. And you have these areas of germinal centers, which are full of B and T cells, which are the immune cells that are going to defend your body. Specifically, remember, we already said that, but remember, the B and T cells are the lymphocytes, right? So these are the ones that are going to do specific defense. We're going to get to that in just a few minutes. Spleen has this red white pulp, and it filters the blood for pathogens. I have a story. Y'all be sure to watch the video for Monday, but I'm not going to retell the story. But I had a young girl who lost her spleen, and it made her very sick. Now, most people that lose it don't get sick, but she was in the kind. And I hate to say this, right? Look. This is the way I see that. Everybody's got something, right? Everybody's got something. Okay, good and bad, right? I'm ugly. I got a good spleen. I got a good immune system. I don't get sick much. I had a girl a couple years ago, one of the nicest, most beautiful women I've ever seen, and smartest I've ever seen. That girl's a walking freaking ER visit. You know what I'm saying? She was sick. I mean, she missed so much days. This wasn't even pre-COVID. I mean, she just got everything. She really got everything. Was sick all the time, man. I mean, I didn't even hate to hire her because she's gonna be what? Out all the time, right? I'm just saying she's gonna miss a lot of work, okay? But we all have degrees of that, right? Like, how many of y'all have no family members or people that have cancer in their family, right? So our genetic predisposition does make some people more likely to get certain diseases. Here's one. If you're one of the sickly people, you don't want to lose your spleen. Now, if you're super healthy, I know another guy that coached here, baseball coach. He lost his spleen in a baseball injury. He got spiked and it busted it, and he never got sick. He's still alive. He didn't even miss a beat. He had it removed. But I do think it is a big part of our immune system, because these B and T cells, these red pulp and white pulp, are areas of immune cells. So basically, the blood is filtered through here, and all the bacterium and pathogens are eaten out of it. Okay. Now, here's a cool one. The thymus, we already mentioned this one in the video. This is in the neck, right? We looked at this in lab. It does make thymosin, the hormone that makes you make more T cells and B cells. This is, though, a weird organ that it is very big in a child. It gets maximum, I think, high. The bigger it gets, it reaches its peak at like 20, and then it starts regressing, and I ain't got one. Sometimes you get 60 or so, you don't have one. And I put this in the video, but I thought this is pretty cool. But this is kind of another little weird thing too. This one makes that hormone. So here is lifespan. This is 1 year old and 70-year-old, and thymosin goes up. And then by the time you get my age, you quit making it. And gee, if you plot that versus death in America, what happens? Old people die. Babies don't die. 18-year-olds don't get infections and die, right? And that's probably what's going on with COVID. Y'all are able to fight it better than us old people, right? But there's a huge difference. I mean, I've had a bunch of friends of mine die in their 70s and 80s with COVID. Matter of fact, one of my good friends of mine who's 81 died yesterday. Or Monday. Really shook me up. He died Monday night. Friend I've had 27 years here in Centovia, and I think it was COVID related. He died of pneumonia, okay, on a ventilator. His wife had COVID, and he didn't get it bad, but I think it affected his lungs, and he got it. got pneumonia. But anyway, isn't that kind of crazy? So we want to try to figure out how to give me y'all's 20-year-old immune system, right? Wouldn't that be awesome, right? If we can pop that back into mama and grandparents, okay? So we're working on that. That's a hormone you can get injections of thymosin. Okay? Now, that's kind of what I covered the other day. I did that in 10 minutes and I spent 50 minutes, okay? Or 40 minutes. So now we're going to pick up the second half of this chapter. And this is the part that gets real complicated. Our lines of defense, okay? And I'm going to go through it kind of quickly, and if I need to, I'll do a supplemental video on Friday or something. But the first line of defense is our barrier. The mucous membrane, skin, the epithelium lining, our respiratory system, our urinary system, our reproductive system, and our digestive system. All those cutaneous membranes and those, the serous membranes, are mucous membranes, are huge lines of defense. If epithelium always did its job, we would have no infectious disease. Okay. However, we know that don't always work. The second line of defense are going to be the neutrophils, monocytes, eosinophils, and other proteins made by the liver that pretty much kill everything. So they're non-discriminatory. And I use this example I'm using again today. To me, a monocyte and a macrophage would be a guard at Fort Knox. At the front with a machine gun that says, shoot anybody that crosses this line if they don't have the right paperwork, right? They don't have the right paperwork. And for us, it's the paperwork, the markers, the antigens that are called MHC markers that are your signature receptors on every cell. So you have a signature on every cell of your body that says Robin. It's like a little receptor, protein receptor. Okay, Ashton says this. Okay, Melissa over here says this. And if anything but this comes into Melissa's body, she kills it. These monocytes and neutrophils shoot it. So a truck running over, the ammunition running, coming up fast, what they gonna do? And they ain't slowed down and stop, they gonna load their gun at them, right? Hopefully stop when they come in with a bomb or something, I mean, kill a bunch more people. So first line of defense are these neutrophils and monocytes that kill everybody indiscriminately. They don't come up and go, hey, let me check your ID. They just shoot you if you cross the line. Okay? But that also fails sometimes. And so the third line of defense are the lymphocytes, the B and T cells, because they do what's called specific immunity. They will go out and kill the Robincoccus bacterium that you picked up last night. We saw that commodity, that ball field, right? Or Cracker Barrel last night, eating it. They didn't clean the bathroom in a long time. So these are kind of like the assassins that go after one particular pathogen. And the other thing that's so crazy about this adaptive immunity, which is mainly B and T cells, they also have memory, so that after the infection has occurred, they make memory cells so that if that bacterium or virus ever gets in your body again, we can kick it before it gets a toehold. Now, I used to do this, and I think most of y'all have this. Everybody here had the chickenpox vaccine? Most of y'all get that? Does anybody not get the chickenpox vaccine? Okay, you should go get that. You should go get that. Okay, because it'll probably prevent shingles when you get my age. But before that, I mean, all of us got chickenpox. I got it in the second grade. I got it in the crack of my foot, in my hair, my scalp. I got it good. I ain't never got it again. Both my girls got it. I never broke out again. That's because I made memory cells. I always used to tell a bad joke. If you got chickenpox real good once and then got it again a couple years later, you got one of them bad immune systems. You roll snake eyes, two ones on the roll of dice for immune system, right? Instead of double sixes. Woo! Double sixes can never get sick, right? We all got different places we start on these levels, right? But you know, how many of y'all know somebody like that? Always gets every little bug comes through. They just got a bad immune system, right? They need to watch themselves, right? They need to stay away from COVID. Stay away. We can keep that mask on, shield up. Okay, so that's what we're going to talk about now for the next 20 minutes is this specific adaptive immunity and how it works, okay? That's the big punchline I want to finish, okay? So innate are include, I'm not going to have time for all this, but the innate non-specific includes the neutrophilic, monocytes, and neutrophils, and there's also some proteins here made by the body called complement that we'll talk about in a minute. Specific ones are the B and T cells, and they recognize the what is called an antigen. The antigen is the structure on a cell that you recognize as not being cell. When we talk about blood today, we're going to talk about the blood typing. I got type O. I make antibodies to A and B markers. Those are A and B antigens. And if you give me one of y'all's A blood, then my blood will coagulate it and I'll die. My blood will clot up because my antibodies will attack it and clot it up. And a clot will kill you when it goes to your brain or to your blood vessels in your heart. So antigens is anything that the B and T cells can recognize. Okay. Now there are two arms of this. There are two parts of this adaptive immunity. Okay, meaning adaptive means it has memory. Okay. The T cells do what is called cell immunity, where they kill cells gone bad by cancer or by viruses. So cellular immunity. So they make cells called killer T cells, and I'll give you one guess what killer T cells do. They kill cells that have been taken over by viruses and cancer. Okay? T cells do cellular immunity. B cells do what's called humoral immunity, and humoral means it's in the blood, it means it's in the fluid, and they make antibodies. Little proteins that look like little molecular mice. Okay, now listen to me on this. I didn't say antibiotics. That's something else, right? Penicillin is an antibiotic made by fungus that kill bacteria. These are real famous for binding to bacteria and marking them to be eaten by the monocyte, neutrophil, and eosinophil, our phagocytic cells. So one of my best metaphors of this, y'all remember, everybody read the Scarlet Letter in high school, right? Which is totally homeschool. I'm joking, I'm just picking. Never read that one? That's like a classic when everybody's supposed to read. But it's a Victorian 1600s, right? 1700s America. And then, of course, the men could go have affairs and they never get in trouble. But a woman who got caught having an affair, she had to wear a letter, an A on her shirt that says adultery. And sometimes get stoned or maybe lit up, for the men get away with it, right? Total, unequal treatment of sexes, right? Crazy. But anyway, the scarlet A means what? You commit adultery, right? Well, a Y stuck on you, an antibody stuck on you means eat me, bacteria. Somebody eat me, I'm bad, I've been infected. So that triggers the B cells, the monocytes and the neutrophils mainly to kill you and eat you. So if you're a defender of the body, a monocyte, a neutrophil, one of those regular defenders, and you see these little antibodies stuck on somebody, you go eat them. So they usually mark them to be killed. Okay? All right, so both of these, that's the two big divisions. Cell-mediated immunity, T cells, and then B cells make antibodies with a cell called a plasma cell. Now, the other thing I want to mention here, I said in the video the other day that y'all watched, but the other thing the T cell does is really important. This has really only been discovered in the last 5-10 years. But it looks like today, and this is still changing, okay? None of this was known when I started teaching here, okay? 1991, that was when the AIDS epidemic hit, and they didn't know anything about this, okay? We didn't know anything about helper cell. Come to find out, there is a T cell called the T helper cell, which seems to be the cell that modulates and controls the entire immune system attack. And guess what AIDS kills? The helper T cell. So actually HIV kills it. AIDS is defined when you have less than like 180 helper T cells per milliliter of blood, and you don't have enough of these to defend for your body to defend itself, and then you die of some secondary third infection like pneumonia or that's Kaposi's cancer, and these guys get these red blotches, and women have AIDS. That's one of the telltale signs of AIDS. If you have these red blotches, that's Kaposi's cancer, okay, which is really rare, and it's only found in people who have an immune system that's knocked out. Okay, so AIDS attacks this helper T cell that seems to modulate the entire immune system, thus the whole AIDS epidemic. Okay, so they interact with each other. Acquired immunity takes 2 to 5 days to mount response. When I get my second COVID shot on Sunday, I'm supposed to wait 2 weeks before I go in. I mean, I should be good to go after 2 weeks after that. But what they're saying now, if you got one shot, even the Johnson & Johnson shot or the one shot I've got, I'm at like 85% chance of not getting COVID. Matter of fact, and by the way, the Johnson & Johnson shot is the old school vaccine using live viruses, like every year, it's made the exact same way that every flu vaccine's been made the last 30 years or 20 years. So if you're OCD or you're scared about the messenger RNA, go get the Johnson & Johnson shot. It's the same as the flu shot. And nobody in the trial who got the Johnson & Johnson shot died of COVID. Nobody got put on a ventilator, nobody died. So that's like crazy good, right? That you get the vaccine and we can maybe get back to normal again. That would be really nice, right? I would like to go to a concert, okay? I would like to go watch her play basketball, right? When there's like 3 people watching y'all, right? Okay, I really want to see you play. Yes, ma'am.
So like, whenever you get the vaccine, that means you can't get it. So like, with that man, once everybody got it, they would stop wearing masks.
Exactly.
Like that.
Exactly.
Like
We don't need everybody. We need about 75% of everybody to get the vaccine. If everybody said it, and look, the day they came out this morning, and this is so cool because it's right now happening, but they actually have gotten enough vaccines to where everybody in America can have a shot on the man. Everybody. even down to 16-year-olds and up. And maybe even kids, okay? But definitely y'all, okay? So if 75% of America gets that, then we're gonna see the numbers fall off to nothing, and we can not worry about the mask. Now, the reason we still wear a mask is because even though I probably can't get it now, I can get it and not get sick and give it to y'all. You know, so you can possibly transmit it and not get sick. So that's why we're still saying wear a mask. And probably the one like my lady Melissa's got might say that's probably the best one to wear because that's what they use in surgery. And the reason they wear a mask in surgery so you won't cause bacteria on somebody's open organs. So those are really good at catching it on your breath out. And they're pretty good at catching it in from coming out. Probably way better than the one I like the fabric ones that some of y'all wear, which I mean, but those are better than nothing, right? But this is really kind of good stuff, right? So my point was, you get the vaccine, you still need a week or two for you to build up these immune memory cells, right? Maybe 2 weeks, okay? But you will see some effect, some acquired immunity after 3 to 5 days. So it's been 3 weeks since I had the first Pfizer shot. So I probably am in pretty good shape probably for that. Okay, and then of course the memory cells are amazing. Okay, let me show you this a minute. We will come to this. I actually jumped ahead of the day and showed this. I'm going to come back and hit this memory. But real quick, it's going to go over the surface ones, right? The first line of defense. So it's some jumping gears now. Now we're going to go back to a little detail. Mucous membranes, y'all got that. That's no problem. That's a great area of defense, right? And then of course our regular B cell, B and T cells are the agranulocytes, right? That's going to be adaptive immunity. Okay, and then the neutrophils, eosinophils, basophils, these make up the that second line of defense, right? They just eat everybody, right? So they're phagocytic cells, and they don't care who you are, they kill you if you're not robbing. So these phagocytic cells, who are the neutrophils and monocytes, they are that second line of defense. Okay, and there's other ones here, like a natural killer cell found in the body that will kill cells that have gone bad. And dendritic cells, same thing. Okay, and then antibodies are these proteins made by the B cells that will bind to pathogens and mark them to be killed. Complement is this set of proteins made by the liver that kind of serve as a poison that bacteria sticks to bacteria and kills them. My metaphor for that is rat poison. You buy rat poison, put it behind the refrigerator, and don't worry about it, right? The bat eats it, it kills them. They take it back to their hive, and then it's heparin, so they all bleed to death. You smell dead rats in the ceilings, right? Hang them all. Okay, so but complement's a weird one here made by the liver. That's a second line defense. Cytokines are chemicals that these cells produce that attracts other immune cells to come in. And that's actually how the helper T cell works. When you get like a step on a nail, then a helper T cell will go to that area and release chemicals to call everybody down there. Now we don't have an intercom system, right? So we can't go get on like the police network and go, we have a wreck on I-55 Coldwater Bridge. We need 13, we need hazmat, we need wings of life coming out to pick somebody up. So we send chemicals in our blood that sends a message, and then our B and T cells follow that trail down to the source. So they actually follow a chemical trail released by the helper T cells or the damaged tissues. Okay. Nothing much here. Just talking about lymphoid organs. Okay. So innate internal defenses. Okay. Moving on. The phagocytic microphage should repeat yourself a lot. So that's still going over the first line of defense, second line of defense. Okay. Now here's an interesting term, and I did get to this. So listen to this. This is asking the questions 5 and 6. How are T cells activated and how are B cells activated? Now I've already told you how I did it before. What's the difference between B and T cell function, right? B cells make antibodies. T cells do what? Cellular immunity and kill cells that have been taken over by viruses and cancer. And they also make the helper T cell that controls the internal immune response, right? Now listen to this real quick. B cells have been isolated since the 70s. Okay. And we can do this. We can take a B cell out of your body, grow it in a laboratory, and they did this back in the 70s. We brought rocks back from the moon, which have a combination of atoms that we don't see on Earth. So we can tell a moon rock is a moon rock. They exposed that to undifferentiated B cells, and they made antibodies to bind to the moon dust. And so we freaked out. Like, how can it know to make antibodies to attack moon dust? That's just the way God did that. So these undifferentiated B cells kind of work like how many of y'all know what I mean when I say vice grips? The wildfires have a little screw so you can make them fit any bolt. Everybody know what I'm talking about? Yeah, you ever seen a pipe wrench, right? You screw it out and you can get a thin pipe or a big pipe. They're adjustable wrenches. Everybody know what I mean? Like those wrenches. Okay. Well, God's B cells are like this. They can be adjusted to attack any combination of the 92 elements on Earth, the universe. So it appears that there's nothing that B cells can't recognize as not robbing and make antibodies that stick to it. Okay, does everybody follow that? So B cells do this humoral defense, and they recognize foreign antigens in the body, even out of the body in the test tube. So we know in your body, B cells can recognize foreign particles and make antibodies to bind to them. T cells can't recognize an antigen on their own. So they have no ability to recognize. They can bump into HIV or coronavirus and others wave at it. They go right by it. They can't attack it on their own. It appears that the helper T cells have to have an APC, an antigen presenting cell. And so what this means is that the monocyte usually is the one that is the APC. It will eat an HIV virus or coronavirus, pull its receptors off and lay it next to its receptor, and then come up to an undifferentiated B cell, or undifferentiated T cell that hasn't been committed to attacking somebody, and they present that antigen to it. And then it becomes totally committed to killing the HIV virus. And then it will clone itself into memory cells and killer T cells and other helper T cells that are like little zombies that want to eat, instead of eating brain, they want to eat or kill HIV or COVID vaccine, the virus or whatever. This was discovered like in the 90s, and they won the Nobel Prize for this. It's the AP antigen presenting cell. So T cells cannot be activated on their own. So for years, we taught in class that B cells can attack antigens on their own in the body, but the T cell has to have what? The antigen presenting cell, and then the helper cell triggers everybody. Come to find out, the most recent evidence is even though B cells can activate on their own, they rarely do in the body. It's all about the helper T cell calling in being T cells to attack the antigen. Okay? Like fascinating stuff. So the APC is a monocyte that presents the antigen to a helper T cell. Neutrophils eat bacteria. The dendritic cells also phagocytic like a monocyte. Eosinophils, remember, attack parasites and help involved in allergies, overreaction of the immune system. Here's a macrophage eating like 6 or 7 bacteria. So they'll grab them, lasso them, and pull them in and eat them. So that's our monocyte. And he will take in a bacterium too and eat and present its antigens to the to an undifferentiated helper T cell. Now, I'll tell a really bad one real quick. When first time I saw this, I'll do a little scenario real quick, okay? Let's pretend, Melissa, I'm gonna pick on you. I know you won't get mad, but you do it. She's gonna be the Melissa Cochran bacterium, okay? And I'm gonna let you be an undifferentiated. Now look, when this first came out, I gotta say this. Please don't get mad at me. But this term helped me understand it. But I think everybody in here knows what a virgin is, right? So what would a virgin B cell or T cell be? One that's never been presented an antigen, right? It makes for so a lot of books use virgin. They call them virgin T cells and virgin B cells. Now we call them undifferentiated. Just means they haven't been exposed to an antigen, so they're not committed to killing somebody yet, right? So we're gonna let you be an undifferentiated virgin B cell, okay? And I'll play the monocyte, okay? So I'm the monocyte, I'm the APC. So I'm coming up to you, I'm like, hey man, I'm Robin. Woo, little Robin Prosper, we're both Robin. That's our marker. So we're Robin, right? Okay. Everybody over here's Robin. Undifferentiated B cells, okay, or T cells, okay? Now walking over here, and I'm like, whoa, got some skank over here. Okay, got somebody that ain't Robin, right? Got that bacteria I picked up on the commode seat last night. I eat her, pull her marker off, put it next to mine. Okay? And then I come over to my undifferentiated virgin T cell and said, oh, don't you kill me, we Robin. But look at what I bumped into down in my foot. On that nail I stepped on. Melissa Cochran bacterium. I show it to you. You go back crazy, start dividing. Everybody now are what? Killer T cells and helper T cells, all Melissa. Okay? And then even my girl on the back is going to be a memory cell. Remember Melissa, if she ever gets back in our body, we don't wipe her out. That's how it works. Is that as good as I ever? Sometimes a little scenario helps me see it, okay? So that's what, so the first time I saw that, guys, I got to tell you what I saw. And my country people here are going to appreciate this. What happens in Mississippi in November on the first Saturday of Thanksgiving? Every male in American Mississippi and half the women go get in a tree and try to kill a deer. Why do we really deer hunt? I have deer hunting. I'm sorry, I don't hunt for the food. I got money, I go to Walmart, right, or Burger King. It's all about the horns, right? I want to kill a big buck so I can have it mounted and hang it in my house, right? I want like the 82 point, Mississippi record deer. I've been in the woods and I had one come out with a broken horn, like a little 2-point, he had like a bad leg. I didn't shoot him. And one time I heard a big deer, and I dropped the gun out of my darn stand in the ground because I was so excited. It was a big deer, right? So this is kind of molecular hunting, isn't it? And they're showing their horns to everybody else. You get it? The markers, to me, that was like horns, okay? But it is markers, okay? Pretty cool. All right, base field's already been there and done that. And there's that, I ain't got time for complement, but complement is this protein made by the liver that help kill things. It's really weird. Read about it, it's crazy. Okay, moving on. How they work, they blow them up, they can mark them to be killed. She goes a little bit crazy. These are all the different ways that a complement can attack and kill cells. Okay, cytokines, these chemicals released by helper T cells and other cells to trigger attack. Interferon is another one that's a protein made that is an antiviral chemical that we actually use for cancer treatment now. We have these made, we can give you interferon shots and they help your body attack viruses. There are 29 interleukins made by all these cells that activate other cells. So the helper T cell is real big. Remember, he's got to call everybody in, and they do it by making chemicals called interleukins and cytokines. Interleukin is a cytokine. It's a type of cytokine. Some new words for you. Inflammation is part of our defense. That's kind of weird. But swelling up and all is part of it. So swelling and pain, when you swell or bust an ankle or get bit, it swells up and all that's part of the defense. So is fever. Okay, fever is a big one. Bacteria can't take the heat in the kitchen and it kills them. Cortisol shots release inflammation. So when we get a bacterial infection, we get a fever and the bacteria die in the heat and we don't. So our cells feel better to take the heat in the kitchen and they can't. That's pretty wild. Willie, hey Willie, didn't mean to quit. That's my Facebook picture. I'm gonna go in. So here we go, summary. Here's the innate ones. I didn't get where I want to get to. Here is the second line of defense. The phagocytic cells, neutrophils, natural killer cells, basophils, complement, all these chemicals that are made by the cells, all that second defense. And the third defense is one I just told you, right? B cells and the helper T cells have that antigen presented. Okay, so I think what I'm going to do, I'm going to come back in here and I'm just going to go through the rest of the chapter on a third Zoom to this chapter, okay? Because there's not much left. I should have just started over here, but I felt like y'all were lost if I didn't. Yeah, because I haven't got the video up for y'all to see. So I will go back and make sure the video is finished. I'll pick up right here. But I'm going to go over that and presenting the cell, okay? Now, the other thing y'all got to do real quick, let me stop this. I'm going to answer your question. Let me stop this real quick so that it'll record. Hang on just a second. Stop sharing. Stop the meeting so it'll record.